Welcome to another Advanced Manufacturing Media webinar. Our presentation today is zCAT DCC-CMM brings portability, 3D accuracy, and economy to the shop. Hello, I'm Patrick Wozniak, Senior Editor at Manufacturing Engineering. Before the presentation begins, I'd like to provide some background on what we'll be doing today. Our sponsor today is Fowler High Precision. Fowler is globally recognized as one of today's leading suppliers of high-quality inspection, leveling, control, and calibration equipment. Since 1946, Fowler has been dedicated to supplying the most innovative products anywhere in the world. Our presenter is Fowler High Precision's Vice President of Sales, Jeff Peterson. For over 25 years, Jeff Peterson has worked in precision technology solutions. His expertise encompasses almost every facet of metrology, from hand tools to sophisticated measuring and calibration systems used to guarantee and certify the most discerning standards. Jeff was introduced to the zCAT in 2010 by its inventor, Homer Eaton. Jeff immediately recognized the zCAT's potential, a new, versatile, highly accurate, portable 3D measuring instrument that is filling the void between advanced height gauges and traditional CMMs. Now, before the presentation begins, a few housekeeping items. During the presentation, you'll be able to ask questions using the Q&A box that appears on the right side of your screen. Time permitting, your questions will be answered following the presentation. If time runs out before we can get to all the questions, we'll make sure the answers are emailed to you. If you have any questions about any other aspects of our webinars, please email me at pwozniak@sme.org. I'll rejoin you after the presentation with a few concluding remarks. Now, here's Jeff Peterson of Fowler High Precision. Jeff?
Thank you, Pat, and I'd like to thank everyone for coming here, and I'd like to thank Pat and Marcus for allowing us to be here today. So today I'm going to go through a presentation about the zCAT, which is the world's first truly portable direct computer controlled coordinate measuring machine. Like Pat said, Homer brought this to my attention about 5 years ago when he invited me into his office in Carlsbad, California, and I immediately recognized that this really fit into what Fowler has been doing for the last 67 years. Been selling precision measuring tools, from hand tools to sophisticated measuring devices, and one of our main products has been the Tremos height gauge, and we've successfully been selling that. I've been successfully selling it since the 1980s. And many customers want to do a lot more than what the Tremos could do. So I immediately recognized that this was the next step. But before we get into that, I'm going to talk a little bit about the inventor, Homer Eaton. Homer has been in the industry for some time, and he's very well known. He actually, back in the 70s, was very successful in a little bit different market, and he invented a machine called the Vector 1, which would actually measure tubing. And it was kind of the predecessor to his next and very well-known product that he invented, was the articulating arm machine. Homer was the inventor, him and his partner, of the Romer arm machine. So his company, Romer, has been around for some time, since the middle 80s, and in a little bit down the road, he did sell that company to Hexagon, and it's still existing today and very successful. But he's always wanted to go to that next level and make his dream was always to make something a little bit more accurate than an articulating arm machine. Wanted to make something that was direct computer control, take away that when a handheld gauge or a manual machine We lose a little bit of accuracy just by having a manual machine. So he's always dreamed of having this, and this is what he introduced to me in his office back in 2010, at least a prototype of this. What we've done is we've partnered with Homer, and we've created a third company that is actually manufacturing zCATs right here in the United States. It's actually manufactured about 30 miles west of us here in the Boston, Massachusetts area. We manufacture them there completely, along with partnering with Homer in a technical arena, and we have our own team working hand in hand with Homer to create these. So you can see the zCAT on this screen. It is small, it's portable, and I've been taking this around the country for the last 18 months to show to many customers, mostly to end users, to engineers, to quality, to inspection, to production people. You can see from the screen here that this is the main control of the zCAT in a standalone mode. The zCAT has its own built-in controller and software, which in this case we call ControlCAT. Therefore, the zCAT can have, you can completely control the zCAT from this touch screen. This is a standard size touch screen that you might find on a cell phone. And it is icon driven, because one of his dreams was to make this very easy to use, very user friendly. So we've made it so that if the operator can just know some simple icons, they can operate the machine. And you can use a stylus to touch the screen and control the zCAT. You could use your finger. You can use different ways of using the touch screen, but if you can use a simple smartphone, you probably can use a zCAT. So you can see on here from the icons, this only shows the A and the B menu, but simple geometric icons can tell it to do an angle in this case, a distance, a diameter, a plane, a line, or a point. We also can do a cloud of points you'll see there. We also have icons for a sphere, a cylinder, or a cone, or a few other things. So all we have to do is identify those, and we can measure those. So we do what we call a teach and repeat method. I'll show you a brief video in a second, but I wanted to talk about, we can completely program the zCAT from this screen, including the speed that the probe is going to move to a maximum of 150 millimeters per second. We can program the approach distance. We can program the measuring speed while it's taking a measurement. We can also, you'll see from the screen here, it has a few other icons, a home, a battery indicator telling you how the battery life is, and we can also print out from this screen. We can do quite a few things. But the other thing that Homer wanted to do was make this completely portable. Obviously, it's important to be able to, if we're going to move this machine around the shop, in this case, it weighs about 30 pounds. So it is very portable. You can pick it up by a handle that's at the top of the gauge. You can move it. You can set it on your desk. You can set it on a conference table. You can obviously set it on a surface plate, which would be the ideal location. But you could even set it on the bed of a machine tool and measure a part while it's still chucked into a device on a milling machine or something. So we wanted to make it as easy as possible to get it to the part or get the part to the zCAT. So in many cases now, we're bringing the cord-to-measure machine to the part. This is one of the reasons production loves this device. In talking about portability, the footprint of the zCAT is very small, so it doesn't take up a whole lot of room wherever you're going to set it. It's a little under 7 inches, and it is held down by gravity. It's very bottom heavy, so most cases I can set it on a surface plate or on a very sturdy table and get excellent repeatability, get excellent accuracy just by setting it there and setting the part in front of it. It has a total height of a little over 24 inches. And it can be, like I say, put anywhere. So you'll see as I go through here a little bit more about about the machine, it has a 700 millimeter radius. So this does not really fit a B89 spec where it's an XYZ machine. The machine is actually a radius Z machine. So there's 4 axes of measuring in the machine. The gauge will rotate actually 360 degrees, and you can nest parts all the way around it if you'd like to. There's a rotary encoder in the base, so when the gauge rotates 360 degrees, you can it will measure anything in that radius. We also have a rotary encoder in the probe for a 360 degree rotation in the probe as well. There are 2 linear scales, one in the Z-axis and one in the cross-axis. So I won't say an X-axis or a Y-axis because of the rotation we have, it creates the X and the Y-axis on a combination of the encoders and the scales. Let me give you a brief video of the zCAT in action using ControlCAT. You can see a touch screen. In this case, we've touched a line and told it we were going to measure a line in 2 points. It takes a minimum of 2 points. I think I physically go in here and touch 3 points on a line on the side of this part. At the end of that, this is what we call our teach and repeat, so I just taught it. Now I'm going to highlight that line and run it under DCC. So now the clutches engage, goes in and takes those same points at the same locations that I took them. Now I'll run this again because you'll also notice on the screen there's some other icons. So before this we did a plane, we did 3 different diameters, we did an angle, and we did a line, but they're all done identically to each other where you go in and you touch them manually. And in this case, when we do it manually, the accuracies and the repeatability are not quite as good as what we would really like, and that was part of what Homer's vision was to do this under DCC. So we actually programmed this gauge to go in exactly at 4 or 5 millimeters per second measuring speed at a perfect vector to the part, because once I've measured that part manually, it knows approximately where that is, but it will go in at a very accurate speed. I'll run that one more time so you can see it, where we touch the line, hit enter. It tells you to take a minimum of 2 points. We're using the vertical probe in this case. So I manually move the gauge by hand and touch. In this case, we've touched 3 points manually. Move it up out of the way, give it a quick go-to. Now I'll run that same thing only under DC again. Place it on the screen, run it. So we get anywhere from 3 to 5 times more accuracy by doing it under DCC, and this is pretty standard among any CMM, but you can imagine having a complete direct computer controlled CMM that you can carry and you can put on your surface plate or on your desk or on your table. Now, here's a little blow-up of the zCAT. This is not official CAD pack diagram by any stretch of the imagination, but it gives you an idea of the breakdown of the zCAT. Again, a rotary encoder in the base. If you look above the base, you'll see, you can see in this case 2 motors. There's actually 4 motors in the zCAT. You'll see the cross-axis there, and kind of broken out, but those motors are driven by, there's a rotary encoder for position purposes only on those motors to drive it to the right location. It will then go to that location and then they'll slow down to the speed where we want to take measurements at. So we're using a combination of Heidenhain and Renishaw rotary encoders, depending on which one we're talking about. We're using Renishaw tape scales in the cross-axis and the Z-axis. They also, the clutches can engage and disengage based on what we've told it to do. So every time we move the gauge manually, the clutches disengage. When we run it under DCC, it then engages, and the rotary encoders for the locations will drive it to the right location. It's a fairly heavy stainless steel construction that we use over a lot of it, a lot of the zCAT. And you'll also notice we're using a standard Renishaw TP20 touch probe. Now, this is a standard in the industry out there. We're using a standard force Renishaw probe with the fixed stylus, one vertical and one horizontal. These stylus are fixed, but the probe actually rotates 360 degrees. So there's no need to have a star, which is somewhat typical among when you have a TP20 stylus in a touch probe. So that probe can actually rotate if we're using the horizontal probe to any position that works. So we basically have to tell the gauge which stylus we're going to use when we're measuring it and measuring with it, because it doesn't know. The TP20 is just a mainstay touch probe, but once we tell it which stylus we're using, the zCAT and the control cat will compensate for the offsets of those stylus. Here's showing a little bit, when we start talking about accuracy and capability. When we want to get accuracy on the shop floor, that's where the DCC really comes in. Because we're going at pre-controlled speeds and almost perfect vectors to the parts, that's no way I could do that manually. I never know how fast I'm going to go in by hand and take those probe hits, and I never know exactly what vector I'm going to be at. And that's really one of the problems with handheld and manual measuring machines, is that we can't control that. But by using control cat or using the zCAT, we now can control that, and now we're getting accuracies much better than we could ever get manually, and our repeatabilities are amazing. Now, I mentioned before that the zCAT doesn't meet B89 spec. Therefore, very similar to what Homer experienced when he invented the Romer arm machine. It didn't meet B89 spec. Therefore, he had to create his own spec for the articulating arm machine, and we're doing the same thing with the zCAT. So what we're doing is we'll be simulating the B89 spec, and here you can kind of see how an operator would typically be using this. But what we're coming up with accuracies are, we'll state a formula based on how much measuring range you're going to use, but if you really want to get into volumetric accuracies that they state in coordinate measure machines, we're getting around 8 to 9 microns accuracies. With the zCAT, we're getting repeatability at 3 to 4 microns, and we have full intentions, and we truly believe we'll even be able to get better than that. But here you can see how an operator would use this gauge, and you can also kind of get an idea the size of the gauge based on the operator. Typical parts that we would use in a zCAT can be from very small to upwards to 20, 24 inches long. Because we do have a measuring range of around 27 inches, but because the gauge does sit in the center and the parts could be around it, we are somewhat limited, like any CMM on the part. You'll also see a standard on this picture. That's a 1-inch precision sphere that we use to do a calibration of the probe and the stylus. Every morning we recommend that they run through a pre-can calibration process that the zCAT does automatically. Basically, you start at the machine, have the option of doing a probe calibration. This is all done under DCC, so it can be calibrated based on the conditions that particular day and where you happen to be. That can be repeated as many times during the day as you need to, again, based on maybe the temperature has changed, maybe the humidity has changed, conditions have changed, whether you're in a lab environment or you're right on the shop floor. So here gives you a little bit of a picture of the zCAT with the probe. We also have a cabling system that drives the zCAT. So the motors actually can drive the zCAT up and down the z-axis and obviously in the cross-axis to compensate for the x and the y-axis. We're using a very sophisticated cabling system on this. It's a high-strength stainless steel synchro mesh cable, and we're using it to drive three of the axes: the z-axis, the cross-axis, or the x and the y-axis. And then when we're rotating the gauge, we're using rotary encoders to drive it or to locate it. And there's two bearings in the base that will rotate it. So we're not using the cabling system to rotate it. When you're looking closely, you can see the cable system and the probes here. There is we do have the capability of doing a lot of service on the gauge if service is ever needed, right at the gauge without a whole lot of problems. But because of the fact that it's portable and it does come in a fitted case that you can transport it, it can be shipped back for repair or service or even calibration at our facility at any time. Unlike the typical CMM you might find out there, that's not really an option. You have to wait for a service engineer to come in and some of that work where we can do some of it internally, or we can have it. We can come out to the customer and do it too. So it's all available and very easy to get to. This is a quick photo of one of the calibration devices that we use with the zCAT. A lot of times customers will ask me, well, how do you calibrate this thing? We actually use 4 different things. One is we start with the surface plate. Obviously, we work off the plane of a surface plate. But then this is a fixture that has a series of 52 spheres at different heights all the way around the zCAT. zCAT actually sits in the middle. We clamp it down. It's all a pre-computer-driven program, and it takes over 5,500 probe hits on the stylus in all different articulations around here. So these spheres are all at different heights, at different distances away from the zCAT, and it's done automatically. After it's finished this sequence, rotate the fixture 90 degrees and do it again. Then we rotate it 90 degrees and we do it again. Rotate it one more time, 90 degrees, and do it again. We also use a series of ring gauge and step gauges to check it. So at the end of it, we can tell the accuracy of each individual zCAT. Now, each zCAT goes through this entire process, and this is also how we would calibrate it on a yearly basis or whatever you've determined you need to have your CMM calibrated. But it can be done in our facility. It can be the gauge can be shipped right back to us, and we can do this in a few hours and ship it back to you. No more waiting for a technician to come out there to do that. We also, with this portability, you can easily have some fixtures to be able to hold parts in certain locations, nest parts around the zCAT completely 360 degrees to do measurements, write programs to do the same part around it, or it can be something as simple as an operator just putting the part in a location and hitting one button and having the zCAT measure that part. Then we can download the data. Now you'll notice an antenna on this zCAT because it is capable of connecting via its own Wi-Fi network. The standard zCAT comes with an Ethernet cable. We do, if we want to hook it to a computer, we do that through an Ethernet cable. We can connect it. We can send raw data into a PC through that Ethernet cable. We can go in. Every zCAT comes with what we call the zCAT wedge, which is a simple program that allows you to input data directly from the zCAT into almost any software package you'd like to. Most people do it into an Excel spreadsheet. It sends that raw data in, the XYZ locations, and depending on the dimensions you're taking, it can do diameters and spheres and angles and every other thing. You send that easily through that, through the Ethernet cable or through the optional Wi-Fi connection. Wi-Fi connections do vary from location to location. Some locations are more conducive to others than for Wi-Fi, so that's strictly up to the end users. But most of our end users have been, really satisfied going with the Ethernet route. We've got end users who are in the medical device industry, measuring small parts that they've created on a 3D printer. In many cases, they don't have a print of that 3D printer, of that part, so the zCATs are capable of exporting that data to create some of those things. We have customers in the gun manufacturing industry where they were using multiple fixtures out on the shop floor right next to the part that's the machine that's making the part, and they initially wanted to use this to support a fixture that was out being calibrated, and because the zCAT's capable of being programmed to do multiple dimensions on a part, the same thing a fixture might be doing, they are capable of replacing that fixture, at least temporarily, until that fixture is calibrated, and then they can rotate the zCAT to another location to take the place of another fixture while it's being calibrated, and so on and so forth. So that's an interesting application. We have mold manufacturers who are using the zCAT to measure the molds, measuring them during the production, and then also while they're being used in production, and if there's any wear on those molds, they can duplicate the program and compare it to the last time they've done it. We've taken the zCAT into Fortune 100 companies in all different industries, as well as the mom and pop machine shop out there that maybe doesn't even have a coordinate measurement. The whole ability of being able to teach somebody how to measure a part or a simple dimension in a matter of minutes and write a program in less than an hour on a zCAT really makes that attractive to them, because they may not have the time or the manpower to send them off to be educated on how to run a CMM over a 1-week period of time of training. And we've had it in companies from all points in between too. Cutting tool manufacturers. We've got cutting tool manufacturers and tool holding manufacturers using it to measure obviously different features on their cutting tools or their tool holding devices. The Department of Energy is probably our biggest user of the zCAT right now, using it in multiple locations for some pretty intricate things that we really can't talk about, but we're hoping that down the road we can get into some of that. But technology has kind of taken us to this level where we can do this. Homer had a dream of doing this type of device years ago before the technology was really there. But now that the technology has come forward and we have the ability to do that, that's kind of where we've come with the zCAT. It's allowed us to bring that technology right to the shop floor and not have to be dedicated to getting it into the laboratory. So this device is very conducive for the shop floor as well as right in the lab. So the next step was really to get it in using full 3D capabilities of it. So because the zCAT has its own built-in I++ software interface, that's included with every one, it's fully capable of interfacing with third-party CMM software packages that use the I++ interface. We have already partnered with a few companies where we are interfacing the zCAT with their software, and we are in communications with other companies too, we have our own software that we've added to the zCAT as an option that gives it full 3D capabilities. This is just a quick little screenshot of that, of doing a part. This was actually done at a customer's location, measuring some dimensions on a tool holder, and these were actually dimensions they wanted us to do to see if it would work for their part, and it worked quite well. This is just a simple little 3D package, very easy to use. We wanted to have a package that we could help teach any operator how to use, whether they're a seasoned CMM professional or somebody who just knows the manufacturing of the part. We could teach anybody how to do this, or they could be, these programs could actually be written offline and using a CAD package. We can create some software something like that. But you can see on here, there's 4 windows in this screen. There's a YZ. Obviously, this is pertaining to which direction we're looking at the part. We have the XY, which is the larger one, and that's looking straight down, and then the XZ. What's really nice about this, when we're doing the teach and repeat mode with the zCAT, we teach it the same way we did in the video where you saw me manually touching off on the part. But in this case, as soon as we're done doing this, it creates that image on the screen, and then with a click of a mouse, we can grab each individual image and pull it out and get those images. We can do true position. We can do G. We can import and export CAD files depending on how in depth the customer wants to get. There are added modules to be able to do this, to do CAD programming or CAD comparisons if that's what they want to do. But we can get as sophisticated or as simple as the customer would like. And we're finding that typical customer wants to be able to make it easy to use, so we can train anybody how to use it. They want to be able to do it have the option of doing it on the shop floor or in the lab, depending on their situation. So that's really where the zCAT has come today. We will be able to answer your questions. If I can't answer them today, we'll definitely we'll get you the answers if you have any that we can't answer. But at that point in time, that's the brief presentation on the zCAT. And if we'd like to go to the question and answer stage, we're more than willing to do.
Hi, this is Pat Wozniak joining you again. Thank you, Jeff, for that very informative session. We have received some questions, and it would be nice to get to all of them before our time is up. Do remember, though, if we run out of time before addressing every question, those unanswered questions will be forwarded to Jeff and Fowler, and a response will be forthcoming. Jeff, let's start with this question. Is this the only size available? If so, are there plans to make a larger model?
Well, today this is the only size that we're making, and if I was to make a guess about the future, I would say that's highly probable that could happen. But right now we're really working full speed at making this size, and it really does fit the size of parts that a high percentage of our customers have. As we know, parts are getting smaller in a lot of cases. Sometimes they may be getting bigger, but it does fit a pretty good percentage. We do want to keep it portable, so we do have to look at that moving down the road. How much bigger can we go physically and still keep it portable? But it's definitely something that we would look at in the future. But for at least the next year, I'd say we're going to be focusing on this size.
What kind of report will this generate?
Well, in its simplest form, we can send all the data off into an Excel spreadsheet, and you can do whatever you can do with Excel, we can do with that. Now, the optional 3D software gives you a lot more flexibility and ease of use when it comes to reports, but we can do full statistical analysis on individual dimensions. We can actually create a print or close to a print of the part. We can bring out all the raw data into a regular file, and that can be converted to an Excel. We can also transport the data into a lot of different SPC packages that people are using. So we can accommodate just about anything, because at the end of it, we're dealing with data. But it's pretty much what almost every CMM software package can give you.
What's the price range of the zCAT?
The list price of the zCAT, the standalone zCAT, with ControlCAT software, with the touch probe, with the calibration sphere, is just under $40,000. It's $39,950. The 3D software package that we are supplying with it as an option is just under $5,000. So it's about $49.50. We also have extended warranty packages available. We have calibration and extended warranty packages available over even up to a 5-year period of time. So if somebody wanted to purchase a zCAT with the software and extended warranty over 5 years, it will include the calibration every year. I might add that there is no licensing fee on the software. There is no yearly maintenance fee. It's lifetime free software upgrades on both ControlCAT software and our MK4 software. So it's really pretty attractive to a lot of our customers.
Can you use different probe stylus sizes?
The stylus size that is included with the zCAT is the one that it's calibrated with at the factory. That's the only mandatory one that we have to have. Now, we can, because it's a standard Renishaw TP20 touch probe, we can accommodate a little bit longer and shorter probes. We can also accommodate a few different sizes of probes. Physically, I think a 1 millimeter stylus might be as small as we would go. I mean, we're not locked into that. The longer we go, like anytime you're using a TP20 with a long stylus, you lose some accuracy by extending it out. But and the farther you extend it out, especially if you're extending it downwards in vertical mode, you lose some of your measuring range. But we can accommodate longer probes and even probes that are, angled. So we can accommodate them, but it's kind of based on applications.
For parts with weird or custom features that aren't easy to define with normal dimensions, can you input a model and compare geometry?
Yeah, we can. We accommodate DXF import and export, step files. So for a lot of different CAD models you might have, we can do a comparison from that CAD file. So it basically would either come out green or red if it's in tolerance or out of tolerance. So but we can accommodate odd shapes too. The software does allow you to measure surfaces and some odd shapes as well. So that is going to be a function of the individual software packages that you might use, but we are currently able to compare like IGES or step files.
Does a zCAT have thermal compensation?
It does. It has a built-in temperature thermometer in the gauge, and it probably didn't notice in the video, but it does show the temperature of the gauge right on the screen. In order to do true temperature compensation, we would also have to be monitoring the temperature of the part and the temperature of the surrounding area too. That would be a software function, but the gauge does have the capability knowing its own temperature, and then it's just a matter of, depending on the software, doing the compensation using the temperature of the part and the.
What is the accuracy of the zCAT?
Again, like I stated before, we'll spec out an accuracy based on a formula how big your part is, but just to make it simple, we're getting accuracies at about 8 to 9 microns and repeatability at 3 to 4 microns. I will say the last zCAT that came off the calibration fixture from one end to the other, the biggest deviation was 11 microns. But again, that's like from corner to corner, and no real part is going to be that. But we have full faith that we're going to keep it at that 8 to 9 micron accuracy for the entire range, and if smaller, get it even down even lower.
What is the biggest part you have measured?
I had a 24-inch head off of an engine block. I could reach pretty much every dimension on that head using both the stylus that are standard on the zCAT. So, again, like any CMM, there is a size limitation. You know, some are very large, and you can drive a car on it. Some are very small, and have a very small part on it. We get, I think that if we convert it, we're at about 27 inches, but again, it has to be able to touch it. If we can touch it, we can measure it. So.
Does it come with a bigger screen?
You know, the standard touch screen that comes on the zCAT, I didn't mention this, but it's actually very easy to use, and it's like I said, it's about the size of a cell phone. And by using a pen or a stylus or even your finger, you can do it. But once we go to the 3D software, that screen basically goes blank. It just has a symbol on there showing you which probe you're using, and then we're using the screen of the computer. So now the computer takes over driving the zCAT, and you're using whatever size monitor you have on your screen. The other day I was at a customer's place where we put it on a big screen television, and it was amazing. I wish we could offer those with the zCAT too. But, so you can accommodate a bigger screen, and that's when we go to the software.
Unfortunately, our time is almost up. As promised, all unanswered questions will be passed along to Fowler, and you can expect a reply via email. Also, this entire webinar will be available for replay by 4 p.m. Eastern Time, and you can access it by using the same sign-in link you used earlier. Beyond our webinar series, SME and Advanced Manufacturing Media have a host of ways to keep in touch with the latest developments in manufacturing. For instance, our September 2015 issue of Manufacturing Engineering included a feature article on measurement and inspection. The upcoming February 2016 issue of Manufacturing Engineering will have a feature article on metrology for medical. SME's membership community features member discussions, certification, event information, and more. Visit connect.sme.org for further information. Advanced Manufacturing Media delivers the latest measurement, metrology, and quality news at www.advancedmanufacturing.org. Thanks for joining us today. We hope you found the presentation informative.